The oxidation number of an atom in the elemental state or uncombined state is always 0. A substance that can readily lose electrons to other substance is called reducing agent or reductant. In the reactant you can see H2S and in the product it is just sulfur. So what is happening here? Hydrogen is being removed. Wherever you are finding hydrogen, generally the oxidation number will be +1, but hydrogen, if it is forming hydrides with metals, then the oxidation number will be -1. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today we are back with session 1 of the next chapter, that is redox reactions. Okay, so today we are going to discuss about redox reactions. We are going to start with the new chapter. We are going to study what is oxidation and reduction, right? As the name suggests, it is redox reaction. That means we are going to study about reduction and oxidation and all of that, right? So we are going to see what is oxidation and reduction first of all in the introduction, and then redox reaction in terms of electron transfer reaction, reducing agent and oxidizing agent, as well as what is oxidation number or oxidation state. All of this we are going to discuss in this session. Coming back to redox reaction, as the name suggests, yes, redox. We are going to study about redox reactions. So from the name itself, you can see this red stands for reduction and ox stands for oxidation. So redox reactions are those reactions in which reduction and oxidation takes place simultaneously. So before we move on to the details of redox reactions, first let us understand what is oxidation reactions and what are reduction reactions. Then we'll move on to redox reactions, right? So beginning with oxidation. So you're already familiar with what is oxidation and reduction reactions, right? Yes. So during oxidation, removal of electrons takes place in different ways. So oxidation is a process in which any one of the following changes takes place. So oxidation, we can define it in various ways. So let's see, the first one is addition of oxygen. Yes, oxidation. So of course it means that we are going to add oxygen. So in a way we can say it is the addition of oxygen. One example is given here, magnesium, to which oxygen is added, we get magnesium oxide. So what is getting oxidized here? Magnesium is getting oxidized. So you can see here it is just the magnesium, and in the product you can see to magnesium oxygen is also added. So what is happening? Addition of oxygen and magnesium is getting oxidized, right? The next one is sulfur plus oxygen gives sulfur dioxide. Right. So here also oxidation of sulfur is happening. Next, removal of hydrogen. Another way of defining oxidation is removal of hydrogen. So either it can be addition of oxygen or else removal of hydrogen. Right. So H2S, hydrogen sulfide, to which Cl2 chlorine is added. What happens? You'll get HCl as well as sulfur. So what you can see here, in the reactant you can see H2S and in the product it is just sulfur. So what is happening here? Hydrogen is being removed, right? So what is happening? Oxidation of sulfur is happening by the removal of hydrogen. So in that way also you can define it. The next one is addition of electronegative element. By adding a more electronegative element, we can say that it is undergoing oxidation. So you can see here magnesium, to which chlorine is added. Chlorine is an electronegative element, right? So what happens? You'll get magnesium chloride. So who is getting, or which element is getting oxidized here? Magnesium is getting oxidized here, right? Next, magnesium plus fluorine. What you get? Magnesium fluoride. Here also magnesium is getting oxidized by the addition of an electronegative element. So fluorine, chlorine, all these are electronegative elements, right? The next one is magnesium plus sulfur. Here also you get magnesium sulfide. Here as well, yes, magnesium is getting oxidized by the addition of a more electronegative element. So these three ways, I hope it is clear, either addition of oxygen, removal of hydrogen, or addition of an electronegative element. The next one and the last one is removal of electropositive element. So an electropositive element, if it is removed, we can also define it as oxidation. So for example, a complex is given here, K4FeCN6, right? And to which we have added water. So what happens here? You can see it is K3FeCN6 and potassium hydroxide you have obtained. So what has happened here? In this complex you can see it is K4 and here it is K3. So what happened? As you can see here, the potassium, which is the electropositive element, it is being removed. So in that way also we can define oxidation. So in general we can say, so oxidation is defined as the addition of oxygen, right? Or else addition of an electronegative element, right? Either of this we can tell, or else it is a removal of hydrogen or a removal of electropositive element. So I hope oxidation is clear. Now the same way we are going to define reduction as well. So let's begin. Reduction is just the reverse of oxidation. That means in oxidation what is happening? Addition of oxygen. So in reduction there will be removal of oxygen. Same way in oxidation there is removal of hydrogen. So in reduction there will be addition of hydrogen, right? So it's the reverse of oxidation. So reduction is a process in which any one of the following reactions will take place. So let's see. First one is removal of oxygen. So the first example you can see mercuric oxide, which is dissociated into, yes, mercury and oxygen. So what happens here? You can see here it is HgO, right? So what happens after dissociation? You can see the Hg and O2 here. So what is happening here? There is a removal of oxygen. You can see it is with oxygen and here the oxygen is being removed, right? So what happens? There is reduction of mercury which is taking place. Okay. So next one is removal of electronegative element. Again, it's opposite of oxidation, right? Removal of electronegative element. So you can see here ferric chloride is taken, FeCl3, to which hydrogen is added, right? We are adding hydrogen, and what happens? We get FeCl2 and HCl. So what is happening here? From here FeCl3 and you can see FeCl2 here. So what happens? Electronegative element, that is chlorine, is being removed, right? Electronegative element is being removed, and that is also called as a reduction process. So the next one is addition of hydrogen. So again it is the opposite of oxidation. In oxidation it is removal of hydrogen. Here it is addition of hydrogen. So this example you are familiar with. It is an alkene to which we are adding hydrogen. So what happens? We obtain an alkane. Okay, we are adding hydrogen. So even this is reduction of ethane. Here also what is happening? Reduction is taking place. The last one is addition of metal. Okay, if we add metal also we can undergo that substance can undergo reduction. So we have taken mercury chloride here, to which we have added stannous chloride SnCl2. So what did we had? Hg2Cl2 and SnCl4. Here also what you can see, we have added a metal here, right? So what happened? Reduction of mercury chloride has taken place. So in either of this way we can define oxidation as well as reduction. So reduction is defined as the removal of oxygen. So either it can be removal of oxygen or removal of an electronegative element, right? Or else it can be the addition of hydrogen or addition of an electropositive element. So either of this you can remember, the exact opposite will be the other one. If oxidation you can remember, the exact opposite will be that for reduction. So I hope oxidation and reduction is clear for you. Now redox reaction in terms of electron transfer reactions we are going to see. That means, so just now we defined or discussed oxidation and reduction in terms of addition or removal of oxygen and addition or removal of hydrogen, yes, and all of that. So now we are going to define oxidation or reduction in terms of addition of electrons or removal of electrons. Okay, so loss of electrons or gain of electrons. In terms of electrons we are going to discuss. So let's see, reactions in which electrons are transferred from one atom to another are called oxidation reduction reaction. So both are taking place. So loss of electron is called oxidation. So how can we define oxidation in terms of electron transfer? In oxidation reactions electrons will be lost, right? Losing of electrons is called as oxidation and gaining of electrons is called as reduction. So I hope that is clear. Let's take one example. 2 moles of sodium reacts with chlorine Cl2 to give 2 NaCl. You're familiar with this example. So as you can see here, sodium, from sodium 2 electrons are being lost. So that means one atom of sodium gets converted into Na plus, or it gets oxidized into Na plus by losing 1 electron, right? It has lost 1 electron. And what else we are having? Chlorine here, Cl2. It accepts this electron. It accepts this electron and forms Cl minus. So how many electrons is required? 2 electrons, right? 2 electrons is required for 2 atoms of chlorine and it forms 2 Cl minus, right? So to balance it, we are going to put 2 here also. So this is the equation, or this is the reaction which is taking place. So that means 2 moles of sodium, it is oxidized into Na plus. by the loss of electron. So how many electrons are being lost from here? 2 electrons, and those 2 electrons are gained by chlorine and it forms Cl minus, and this Na plus and Cl minus will combine and form sodium chloride. So I hope that is clear. So this is the reaction which is shown here. As you can see, sodium loses its 2 electron and forms 2 Na plus. So that is what is shown here. This is how you have to represent reduction and oxidation in the same reaction. So you can draw a line like this and show which is undergoing oxidation and which is undergoing reduction. So in here, sodium is losing 2 of its electrons. So what reaction is happening here? Oxidation is taking place, right? Oxidation. And chlorine, what happens to chlorine? That 2 electrons is being accepted by chlorine, that is gain of 2 electrons, it forms 2 Cl minus. Okay, so what process is happening or what reaction it is? It is reduction reaction. So in the same reaction, you can see reduction and oxidation taking place. So this type of reactions is called as redox reaction. So I hope it is clear. Now let's move on to another example, right? Again, we have taken sodium, 2 moles of sodium, to which we add oxygen. We get sodium peroxide. We get Na2O2. So in this example also, you can see that sodium is getting converted into Na plus, right? It is getting oxidized. And how many are there? 2 Na plus. That means how many electrons are being lost? There is a loss of 2 electrons, right? So what type of reaction is taking place? It is an oxidation reaction which is happening here. 2 electrons are being lost. And in case of oxygen, you can see it is gaining of 2 electrons and it forms O2, 2 minus. You can see the 2 minus there. That means there is gain of 2 electrons. So reduction process or reduction reaction is taking place. So I hope that is clear. Now the next one, again sodium combines with sulfur and forms sodium sulfide. Here also you can see 2 electrons are being lost from sodium. It undergoes oxidation and forms Na plus, right? And how many Na plus? 2 Na plus. So what happens? There are loss of 2 electrons. Again, this is an oxidation process or oxidation reaction. And here, yes, the sulfur accepts these 2 electrons or gains 2 electrons and forms S2, 2 minus. That is 2 electrons are being gained. So this is a reduction process. So I hope in terms of electrons also, redox reactions are clear for you. So in oxidation, there will be loss of electrons and in reduction, there will be gain of electrons. Right? So I hope it is clear. Now let's understand what is reducing agent and oxidizing agent. So you understood in terms of oxygen, hydrogen, electrons, what is oxidation and reduction. Now we are going to study a new term, what is oxidizing agent and reducing agent. So it's not the same as oxidation and reduction. This is oxidizing agent and reducing agent. So let's begin with the first one, reducing agent. A substance that can readily lose electrons to other substance is called reducing agent or reductant. So another name for reducing agent is reductant. So those reducing agents or reductants are substances that can easily lose electrons. They are ready to lose electrons. So reducing agent are those substances which undergoes oxidation, right? Just now we discussed what is oxidation. Oxidation is the process in which there is loss of electrons, right? So those substances which are ready to lose electrons easily, they will undergo oxidation, right? So reducing agents will undergo oxidation or reductants will undergo oxidation. Okay, yes. The next one is oxidizing agent or oxidant. A substance that can readily accept electrons from other substances is called oxidizing agent or oxidant. So here also, how can you define it? Yes, it is those substances which can easily gain electrons. So what type of reaction is taking place? It is reduction, right? So what does that mean? Oxidizing agents or oxidant undergoes reduction and reducing agent or reductant undergoes oxidation. Okay, and so reducing agents are electron donors. They are electron donors and oxidizing agents are electron acceptors. So it is in the opposite way. You have to be very careful here. Reducing agents will undergo oxidation and oxidizing agents will undergo reduction. So I hope that is clear. So now we are going to move on to an important part of this chapter, that is oxidation number or oxidation state. Okay, so oxidation state or oxidation number of an element in a compound is the real or apparent charge on one atom of the element. So it is the real charge or apparent charge on an atom of an element. So let's take an example. Oxidation number of sodium in sodium chloride is +1. Since the real charge on one atom of sodium in sodium chloride is +1. So let's take the example of sodium chloride. So what does that mean is oxidation number of sodium in sodium chloride we are discussing. That means the oxidation number of sodium is +1. Right, it is +1. It is the real charge of sodium itself. Similarly, the real charge on one atom of chlorine in sodium chloride is -1, and hence the oxidation number is also -1. So it is not necessary it is always the real charge. It can be an apparent charge also. So how can you determine all this oxidation number or oxidation charge? It is based on a set of rules. So once you are clear with the set of rules, we can identify or we can calculate the oxidation number for any atom given in a compound, right? So oxidation number of hydrogen and oxygen in water are +1 and -2 respectively. Since the apparent charge on each atom of hydrogen and oxygen are +1 and -2 respectively. So in water, right, in water the charge on oxygen is -2 and on hydrogen each atom of hydrogen is +1. Okay, so that is the apparent charge given here. So to understand better about the oxidation number, how you can determine it, we are going to study a set of rules here. So once you are clear with that, you will be able to calculate the oxidation number. So let's begin with the first one. The oxidation number of an atom in the elemental state or uncombined state is always 0. If the element is in its elementary state, okay, or uncombined state, always its oxidation number will be 0. So for example, Cl2, H2, O3, S8, sodium, Na, magnesium, aluminium, these are all in its elementary state. Right, sodium exists as sodium metal, right, that is in the solid form. So that is in an uncombined form, always the oxidation number will be 0. Hydrogen, it doesn't exist as hydrogen atom, right, it exists as H2, hydrogen molecule. So that is in its elementary state. So what happens? The oxidation number will be 0. Okay, now moving on to the next rule, the oxidation number of an ion is equal to its charge. So what is ion? Either it can be a cation or anion by losing or gaining of electrons. So just now we discussed an example, sodium getting oxidized to Na+. Right, this is a cation now. So what is the charge on this or the oxidation number of sodium in this case? It will be +1. That is exactly equal to the charge on the ion. So Na+ has an oxidation number of +1 because the charge is +1 here. Right, whatever is the charge, that will be equal to the oxidation number. For Cl- it will be -1. For Mg2+, it will be +2. Right, it will be +2. Okay, so in the case of ions, the oxidation number will be exactly equal to the charge on the ion. Next one, the oxidation number of hydrogen in all compounds containing hydrogen is +1. So wherever you are finding compounds having hydrogen, the oxidation number of hydrogen in all those compounds will be +1, except there is an exception here when hydrogen forms compounds called as hydrides with active metals in which it is -1. So wherever you are finding hydrogen, generally the oxidation number will be +1, but hydrogen, if it is forming hydrides with metals, then the oxidation number will be -1. For example, let's take water. In the case of water, the oxidation number of hydrogen will be +1. Right, but if we are taking the case of sodium hydride, it is forming a hydride, it's called as sodium hydride. In this case, we should not take the oxidation number as +1, it will be -1. Okay, so I hope that is clear. Now the oxidation number of oxygen in all compounds containing oxygen is -2. Again, like hydrogen, wherever you find oxygen, the oxidation number will be -2, except in two cases. One is peroxides. For peroxide, the oxidation number of oxygen will be -1, and superoxide, it will be -1/2. These 2 points you have to remember. For example, again we are taking water. Okay, so in case of water, just now we discussed for hydrogen, each hydrogen atom, it will be +1. The oxidation number will be +1. And oxygen, as it is not a superoxide or peroxide, the oxidation number will be -2. Now, you can see the oxidation number is -2. And in the case of hydrogen peroxide, H2OH2, can I take -2 here? No, right? The oxidation number will be -1 as it is a superoxide. So, you have to be careful in the case of hydrogen as well as oxygen. Hydrogen, when it is forming hydrides, it is -1. In all other cases, it is +1. Oxygen, if it is forming superoxides, it is -1. In all other cases, it is -2. So, I hope it is clear. Now, moving on to the next rule. The algebraic sum of the oxidation numbers of all the atoms present in one molecule of a compound is 0. That means what? Let's take the example of sodium chloride itself. Okay. So, just now we discussed sodium, it is +1, right? And chlorine, it will be -1. So, if you're taking the algebraic sum of the oxidation numbers of each of the elements which is present in the compound. So, you have sodium, which is having +1, right? Oxidation number is +1, and chlorine, it is -1. So, if you add these two, +1, -1, it will be 0, right? The algebraic sum should be equal to 0, right? Now, the next one, the algebraic sum of the oxidation number of all the atoms in the formula of a polyatomic ion is equal to the charge on that atom. So, you can see here NaCl, it doesn't have any charge, right? For example, if I am taking SO4 2-, if I am taking SO4 2-, if I am adding the oxidation number of sulfur and oxidation number of oxygen, right, it should be not equal to 0, it should be equal to -2. That is what it means. In case of sodium chloride, you don't find any charge on top of it, right? It is a neutral molecule. But in this case, SO4 2-, there is a charge. So, if you add the oxidation number of sulfur and oxygen, it is equal to -2 and it is not equal to 0. I hope it is clear. Now, moving on to the next one, the oxidation state of halogen in their compounds is -1. For halogen, it is -1. But in interhalogen compounds of chlorine, bromine and iodine, the more electronegative of the two halogen gets the oxidation number -1. So, generally, if you find halogens, the oxidation number will be -1. If it is interhalogen compounds, that means both the elements are halogens, then the more electronegative one out of the two will get the -1. Right? Okay. The next one is the oxidation number of alkali metals in their compounds is +1. Alkali metals, that's the first group metals. Lithium, sodium, potassium, rubidium, cesium, francium, the first group elements, always their oxidation number will be +1. And the second group, that is alkaline earth metals, always their oxidation number will be +2. Okay, that is beryllium, magnesium, calcium, strontium, barium, radium. It will be +2. So, for example, oxidation number of potassium in KMnO4. So, even though you don't know the oxidation number of manganese, you can calculate it because you already know the oxidation number of oxygen. KMnO4 it is, right? KMnO4, right? For oxygen, just now we discussed, it is -2. It's not a peroxide or superoxide. So, it is -2 for one atom. How many you are having here? 4, right? So, together it will give you 8. And potassium, it belongs to the first group, that is alkali metals. So, always it will be +1, right? And manganese, I don't know, I can keep it as X. So, what does that mean? If I add all of this, it should be equal to 0. That is this rule, right? It should be equal to 0. It doesn't have any other charge. It's not a charged species. So, it is equal to 0. So, 1 plus X. For manganese, I don't know. I have to calculate it. I put X here and -8. How come it has become -8? It is 4 into -2. For one oxygen atom, it is -2. You have 4 of that. So, it will be equal to 0, right? So, X minus 7 will be equal to 0 and X will be equal to +7. So, how am I doing this calculation? In the upcoming slides, we are going to do in detail and we are going to do many problems based on that. So, we were discussing that potassium, as it is a alkali metal, always in a compound, the oxidation state of alkali metals will be always equal to +1. So, these are the rules that you have to be very clear about. Then only you can calculate the oxidation number of other metals or elements. So, in this case, we just calculate the oxidation number of manganese. So, now we are going to do few examples here, how we can calculate the oxidation number based on the rules that we have just discussed now. So, first let us calculate the oxidation number of sulfur in sulfuric acid, that is H2SO4. So, we already, based on the rules that we have studied, we already know the oxidation number of oxygen and oxidation number of hydrogen. So, using that, we are going to calculate the oxidation number of sulfur. So, as of now, we don't know it. So, we are going to take it as X. right? We are going to take it as X. So as you can see, H2SO4, it is not a hydride. So except in hydrides, in all other cases, the oxidation number will be +1, right? It will be +1. And for oxygen, it will be -2, right? Okay. So I hope that much part is clear. And how many atoms of hydrogen is here? 2 atoms. So what we have to do? 2 into +1. Right, for one atom, it is +1 oxidation number. So how many you are having? 2 here. So you write 2 into 1. And what else is there? X. Right, sulfur we don't know, so we keep it as X. So 2 plus X plus 4 into -2. Why 4 into -2? For one oxygen, it is -2. So how many are there? 4. So 4 into -2 will be equal to 0. Why it is equal to 0? It is not having any charge, right? It is H2SO4. It must be equal to 0. The algebraic sum of the oxidation numbers must be equal to 0. So that is why the 0 is here. So if you simplify, it is 2 plus X minus 8 is equal to 0 and X will be equal to +6. Yes, this is how you calculate. So in sulfuric acid, what is the oxidation number of sulfur? It is +6. And it is very necessary to mention the charge as well. It is +6. Right. Moving on to next one. This is potassium dichromate K2Cr2O7. So again, what is that I have to calculate for chromium? So I put chromium as X. I don't know. So it is X. That is what we have to calculate. And for potassium, it is +1. For one atom of potassium, it is +1. Why? Because the reason is it is an alkali metal or the first group metal. So it is +1. And oxygen, again, it is -2 for one atom of oxygen. So now let's start calculating. So how many atoms are there? 2. So it is 2 into +1, right? 2 into +1. Plus, why I have written 2x here? Yes, again you have 2 atoms of chromium here. It's not just 1. So instead of taking x, you have to take 2x, right? 2x plus 7 into -2. 7 atoms. So 7 into -2, again it will be equal to 0. So 2 into 1 is 2. 2x again here. 7 into -2 is -14 is equal to 0. -14 plus 2 is -12. 2x is equal to 12. So if you are taking -12 to that side, it becomes +12, right? So 2x is equal to 12 and x will be equal to +6. So what is the oxidation number of chromium? It is +6. Now moving on to the next one, that is Fe2O3. So let's follow the same step. As we don't know the oxidation number of iron, we are keeping it as X. And for oxygen, we know that it is -2, right? For one atom, it is -2. So there are 3 here. So 3 into -2 we have to do. So let's begin. So iron, how many atoms are there? There are 2. So should we take X or 2X? It will be 2X, right? So 2X plus 3 into -2. There are 3 atoms. So 3 into -2 will be equal to 0. 2X minus 6 will be equal to 0. 2X will be equal to 6 and X will be equal to +3. I hope it is clear. Now moving on to this one, Mn2O7. So here also, I don't know what is the oxidation number. So we keep it as X. For oxygen, it is -2. So how many atoms of manganese are there? There are 2. So 2X plus 7 into -2, right? So 7 into -2 is -14. 2x will be equal to 14. X is equal to +7. So I hope it is clear. So let's do few more examples here, right? So the first one is here is MnO4 minus. So there is a small change in this particular example. Why? Because all these examples that we have discussed now, it is not having any charge. Right. So this is having a charge. So it is equal to 0. We can't write. The algebraic sum will be equal to the charge on that substance. Okay. So let's take this example. So again, manganese, I don't know. So I'm going to take it as X. There is only one atom of manganese. So no need to take 2X. It is just X. And for one atom of oxygen, it is -2. The oxidation number is -2. How many are there? There are 4. So 4 into -2 will be equal to what? Will be equal to -1, right? The charge here you can see it is -1. So it won't be equal to 0. It should be equal to -1, right? So X, 4 into -2 is -8 is equal to -1. And this -8 I am taking to that side. It becomes 8 minus 1. So X will be equal to +7. So what is the oxidation number of manganese? It is +7. So I hope it is clear. So when you have a charge there, it must be equal to that charge. It's not equal to 0. So now moving on to the next example, Cr2O7, 2 minus. Again, you have charge here. So as I don't know the oxidation number of chromium, I'm going to take it as X. And how many atoms are there? There are 2. So we write 2X, right? 2x, and for one oxygen it is minus 2, right? For one oxygen it is minus 2, and how many you are having? 7. 7 into minus 2 will be equal to 0. No, it is equal to minus 2, right? This charge we have to mention. So 2x minus 14 will be equal to minus 2. 2x is equal to this minus 14, we are taking to other side, it becomes plus 12, right? 14 minus 2 is 12, and x will be equal to 12 by 2, that is plus 6. Okay, so plus 6 will be the oxidation number of chromium. Now moving on to the last one, that is HSO4 minus. So in HSO4 minus, okay, so for hydrogen, as it is not a hydride, we already know what is the oxidation number. It is plus 1, right? Sulfur I don't know, so I take it as X, and for oxygen it is minus 2, right? So now let's add all this. For hydrogen it is 1 plus 1. So we write that. For sulfur it is X, only one atom, so X. And for oxygen it is 4 atoms. So 4 into minus 2 will be equal to what? 1 minus charge is there. So it is equal to minus 1. So 1 plus X, 4 into minus 2 is minus 8, is equal to minus 1. 1 minus 8 is minus 7, right? X minus 7 will be equal to minus 1. X is equal to 7 minus 1, and X is equal to plus 6. Okay. So the oxidation number of sulfur in HSO4 minus is also plus 6. So I hope it is clear, right? So if you are clear with the rules of the oxidation number, you can easily calculate the or easily assign the oxidation number for each of these elements. So in the next session, we are going to study about stock notation, and we are going to further continue with that. So I hope the concepts that we have cleared in this session is clear for you. So that's all for today. Thank you.